What is entropy of mixing? Have you ever wondered what happens when you combine different substances? The answer lies in a fascinating concept called the entropy of mixing. This term refers to the increase in disorder that occurs when two or more different substances are mixed together without any chemical reaction taking place. In thermodynamics, entropy is a measure of randomness or disorder in a system. When you mix substances, the particles have more possible arrangements than when they are separate. This increase in possible positions leads to a higher entropy. Let's picture this with a simple example. Imagine two gases that are initially separated by a wall. When that wall is removed, the gases start to mix. Each type of molecule can now spread out and occupy a larger space. This means there are more ways for the molecules to arrange themselves, resulting in an increase in entropy. For ideal mixtures, the entropy of mixing is always positive. This means that mixing happens spontaneously and increases disorder. The molecules become more randomly distributed, making the system more likely and less organized than it was before mixing. Now, if we look at the math behind it, the change in entropy due to mixing can be calculated using the mole fractions of each component. If we denote the mole fractions of two substances as x1 and x2, the formula for the entropy of mixing is expressed as follows. The change in entropy of mixing equals negative n times r times the natural logarithm of x1 plus the natural logarithm of x2. Here, n represents the total number of moles, and r is the ideal gas constant. The natural logarithm terms show how the distribution of molecules changes. Since mole fractions range from 0 to 1, their logarithms are negative, making the overall change in entropy positive. This principle applies not only to gases but also to liquids and solids when they form mixtures or solutions. This is especially true for ideal solutions, where the interactions between molecules do not significantly affect the mixing process. Understanding the entropy of mixing is important in various fields. In chemical engineering, it helps in designing stable mixtures. In environmental science, it aids in predicting how pollutants disperse. In food technology, it is essential for controlling the blending of ingredients. In essence, the entropy of mixing is a thermodynamic measure of the increase in randomness when substances combine. It reflects a fundamental principle that mixing leads to a more disordered and therefore more probable state. So, the next time you mix substances, remember that you are witnessing the fascinating world of entropy in action.